Bismillahirrahmanirrahim. Assalamu alaikum and a very good morning to all of you. Dear student, today I am going to give you the lecture about electrochemistry, and this one is a chapter 7 there in ninth grade chemistry. In today's lecture, we will discuss about oxidation and reduction, oxidation states, rules for assigning oxidation states, and how we can determine the oxidation numbers. So let us start. First of all, what are oxidation and reduction? Oxidation क्या है, reduction क्या है? So in simple way, I write three definition of oxidation for you: gain of oxygen, loss of hydrogen, loss of electron, and increase in oxidation number is oxidation. If you memorize the four definition of oxidation, same there are four definitions of reduction. Yani loss of oxygen, gain of hydrogen, gain of electron, decrease in oxidation number. Next, what is oxidation number? Oxidation number is an apparent charge on an atom in a molecule or a compound. So first of all, you must know about the definition of oxidation number. Now next, how we can assign the oxidation number on an atom in a molecule. So for that, we must memorize first the rules. The rule number one is the oxidation state of any uncombined or free element is zero. Rule number two, here I give the examples for this rule number one, like for example H2, it will be considered as uncombined and in free state and its oxidation state will be zero. Like S8, because if same atoms are there and it may form like Cl2, Br2, so its oxidation state will be zero. Same zinc, it can exist in this free state, sodium, so all they will have the oxidation number 0 in uncombined form. Rule number 2, in simple ions, oxidation state is same as their charge. For example, oxidation state of Na in Na plus 1 and calcium it has Ca plus 1. Rule number 3, in complex ion, the total sum of oxidation state of atom is always equal to 0. It's very important rule. So for example, this one is a complex ion carbonate CO3 minus 2. So when we take the sum of oxidation number of carbon and oxygen, it should be equal to minus 2. So look at here, NH4 plus 1. When we calculate the oxidation number of nitrogen and hydrogen, the sum should be equal to plus 1. Rule number 4, the oxidation number of each atom in a molecule or a compound count separately. So we will count separate and their algebraic sum is 0. For example, in HCl, the sum of the oxidation number of hydrogen and chlorine must be equal to 0. So plus 1 minus 1, total 0. Same in CO2, the sum of oxidation number of 1 carbon and 2 oxygen, it should be equal to 0. Here the rule number 5, there are some element in binary compounds. Their oxidation states are rarely changed. Like all the elements which are present in group 1A, their oxidation state is plus 1. All the elements which are present in group 2A, their oxidation state plus 2. All the elements which are present in group 3A, their oxidation state plus 3. Hydrogen generally its oxidation state is plus 1, except in metal hydrides its oxidation state is minus 1. Group 7A, their oxidation state is minus 1 because they require 1 electron to complete their octets. Oxygen in normal oxide, its oxidation state is minus 2. Now how we can determine the oxidation number of a atom in a given molecular compound? Like for example, the compound is here is KMnO4, potassium permanganate. And if we want to calculate the oxidation number of Mn, how we can calculate? So potassium, it has plus 1 charge. 1 oxygen, it has minus 2 charge. 4 oxygen, minus 8. Sum should be equal to 0. It means that the value of X, yani oxidation number of Mn, it will be plus 7. So in this way, total should be 0 and oxidation number of Mn is plus 7. I can give you another example. Look at the famous example, determination of the oxidation number of chromium in potassium dichromate K2Cr2O7. Oxidation number of the potassium, it belongs to first group of periodic table, plus 1, and these are 2, so these become plus 2. Oxygen, 1 oxygen minus 2, 7 oxygen minus 14. So total should be equal to 0. It means that the value for this Cr2, chromium 2, it will be minus 12. When it go on another side, it will be plus 12. And this value is for 2 chromium. For 1 chromium, value is plus 6. So oxidation number of chromium in potassium dichromate is plus 6. More example is here. If suppose you want to determine the oxidation number of boron in boric acid H3BO3. So simple, oxidation number of the hydrogen is plus 1. So there are 3 hydrogen, so it will be plus 3. Oxidation number of oxygen is minus 2. So there are oxygen total 6, so it will be minus 6. And total sum should be 0. So value for the B, look, it should be plus 3. And if the B, it has plus 3 value and hydrogen plus 3 and oxygen minus 6, total should be 0. So in this way we find the oxidation state of boron, that is plus 3. One more example is here. If we want to determine the oxidation number of the nitrogen in nitric acid, look, hydrogen plus 1 oxidation state, oxygen minus 2, and there are 3 oxygen, so total should be minus 6. And the value for the nitrogen, it will be plus 5. So in nitric acid, the oxidation state of nitrogen is plus 5. With this one, I am going to end by this lecture. Inshallah, in next lecture, we will talk about more about the electrochemistry. At the end, just my message is, please keep on watching my channel, Amjad Ali 1522, and subscribe it.